Right, for this tutorial we're going to look at some exam type questions on scientific notation. So the first one we have here, the distance between the Earth and Mars is on average approximately 1.65 times 10 to the power of 8 miles. A spaceship has been designed to travel between the Earth and Mars at an average speed of 20,000 miles per hour. How many days will the spaceship take to reach Mars? Give your answer to the nearest day. So we're looking for the time it's going to take. We know the distance and we know the speed. So we know that we work out time by doing the distance divided by the speed. So time equals 1.65 times 10 to the power of 8. So that's our distance. I'm just going to write beside it divided by 20,000 because that's the speed there. So once you've worked out what you have to do, you're just going to put that into your calculator. So 1.65 times 10 to the power of 8 gives us this number, and then we're going to divide that by 20,000. So the time we're going to take is 8250. And because our speed is in miles per hour, our time will be in hours. 8,250 hours. And we've been asked to give our answer to the nearest day. So if it's 8,250 hours, to change it into days, we're going to have to divide it by 24, the number of hours in each day. So we've got 343.75 days. So the nearest day, that's then just going to round up to 344. So 344 days. All right, let's look at another exam type question on scientific notation. So this one says the population of Scotland in June 2001 was 5.06 times 10 to the power of 6 people. Population of China in June 2001 was approximately 250 times larger than that of Scotland. Calculate correct to three significant figures the population of China in 2001, expressing your answer in standard form. So standard form is another name for scientific notation. So it was 250 times bigger, so we're just going to take the population of Scotland, which is 5.06 times 10 to the power of 6. And we were told that it's 250 times bigger, so we're going to multiply that by 250. Right, so let's get our answer. So we do 5.06 times 10 to the power of 6. So this was the population in Scotland, and we multiply that by 250. So we've got this answer here, 1265, and then just be careful, I'm just going to check my calculator. So 1, 2, 3, 4, 5, 6 zeros, 1, 2, 3, 4, 5, 6 zeros. Right, I'm going to now write this out to three significant figures first, because we've been asked to express the answer correct to three significant figures, and then I'm going to change it into scientific notation. So if you're not sure of how to do significant figures, have a little look at this significant figures tutorial. But here's our first, second, third significant figure. And so this 5 is going to tell us to round that 6 up. So 1, 2, 7. Then everything after it becomes a 0. 1, 2, 3, 4, 5, 6, 7 zeros there. And now converting that into scientific notation or standard form, we have 1.27 multiplied by 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 to the power of 9. And that's your answer there. Correct to three significant figures for the decimal here, and in scientific notation, times 10 to the power of 9. Right, we're going to look at one more exam type question. This last one says, the Blackbird is a two-seater high-speed jet. In December 1964, it broke a world record speed by travelling at 1.02 times 10 to the power of 4 metres per second. Calculate correct to three significant figures the distance travelled if the jet were to maintain the speed for 1 hour. Express your answer in scientific notation. So first thing we might notice is that we've given the speed in seconds, but we've been told to do it for 1 hour. So first thing you have to do just before we can do anything else is change the 1 hour into seconds. So there are 60 minutes in an hour multiplied by 60 seconds. So we've got 3,600 seconds for the hour. So 1 hour is 3,600 seconds. So now we can use this. So calculate correct significant figures the distance travelled if the jet were to maintain this speed for 1 hour. So we take the speed 1.02 times 10 to the power of 4, and we multiply it by 3,600 seconds. Then we can get our calculator. 1.02 times 10 to the power of 4, so that's the speed, multiplying it by 3,600, and we've got 36720, 0, 0, 0. Once again, it asks us to give it to correct to 3 significant figures and in scientific notation. So just changing this to significant figures, we've got 1, 2, 3. So that 2 is going to tell us to keep the 7 as it is. The 2 is going to turn to 0, and then we've got 1, 2, 3, 4 zeros still. Alright, 3 significant figures we've got, and now we'll change it into scientific notation. So 3.67 times 10 to the power of 1, 2, 3, 4, 5, 6, 7. And it was meters. So the distance travelled will be 3.67 times 10 to the power of 7 meters. And you're ready to try some past paper questions on scientific notation.